This is Project 1.3 Accounting Circuit. It is split up into 9 parts, each of which play a fundamental role in the circuit's functions. The counting circuit can count 0 to 99 in decimal, shown through the segment display. It uses a variety of digital components to track binary coded decimal, which gives off signals through oscillation within the circuit. The button input introduces a new function which is used in the next stage of this project. The pull-up resistor keeps the LED high at rest and low at use. Due to this, it serves as a starting button for the final counting circuit. The NAND gate oscillator is mainly controlled by capacitors and NAND gates. RC1 serves as the timing of the circuit, whereas RC2 controls the oscillation speed. By connecting the input of a NAND gate to the output, it serves as a continuous loop. Using resistors and capacitors to filter the timing, it creates oscillation, which can be viewed through the LED in square wavelengths. When the LED blinks on and off, or the clock signal goes high to low, this is considered one full oscillation. The decade counter uses the 4017 IC to harness the NGO's oscillation and use it for 10 LEDs, which receive high and low in order, relying on the oscillation to receive a signal. This IC also has a divide by 10 pin, which takes the oscillation and slows it down to 1/10 of the received signal. In the counting circuit, this chip is only used for its divide by 10 pin. The decimal binary up/down counter counts in binary from 0 to 15 or in binary 0000 to 1111. The 4510 IC takes the 1/10 oscillation output from the decade counter and uses internal logic to output signals to 4 LEDs in a determined order to make it appear as binary. It does this by giving oscillation to each of the 4 LEDs, which gets slower for each LED. The 4510 chip gives access to a reset pin, which is actively low, and when high will reset the count to 0000. Next, it has an up/down counting pin, which lets the circuit count low to high at voltage and high to low at ground. Lastly, the IC has a preset function pin, which can be toggled by a certain pin which the operator wants the counting to start at being inputted into the preset pin. The binary counting decimal decoder introduces the final chip to the counting circuit, which is also the final part to the single-digit counting. The 4511 IC pairs with the 4510 and 7-segment display, which will be talked about in the next section. The 4511 IC uses internal code to receive a number through binary and output it to decimal with predetermined segment signals per number. This IC has functions which include a display test pin, which turns on all the LEDs when toggled high, a blank input pin, which when toggled high turns off all LED segments, and finally a store pin, which keeps displaying the current number. For all of these inputs, the IC continues to count internally. Additionally, this circuit also allows for a potentiometer to be a replacement for the 330K resistor in the RC2. It can change the speed of how the circuit counts. The 7-segment display is used in the counting circuit to display the number which is received through the 4511 chip in binary. It includes inputs for the segments labeled A to G, which match the 4511 IC. Displays come in either common cathode, which is used in the counting circuit, where the pin that's connected to all LEDs is ground, or common anode, which has a voltage pin connected to all the LEDs. The PCB and PCB case are separate parts, but they'll be combined for this video. The PCB is a more permanent build of the prototype where components must be soldered in, but gives restrictions like no potentiometer and none of the IC exclusive functions except for the up/down counting. Another difference is that the PCB has an on-off switch, which is not used in the prototype. The case has a slot for a 9-volt battery to be stored, but it is important to wrap this battery in electrical tape so it does not interfere with any of the soldered components. The final part of project 1.3 is dual digit counting circuit. It is made up of two 7/7 displays which can count from 0 to 99. The second digit takes the divide by 10 output and inputs it into another divide by 10 input, making it count 1/100. From there, the steps are repeated, and instead of having two switches for each digit using reset or up/down counting, the second digit functions are wired to the corresponding switch of the first digit, effectively connecting them to work in sync. Thank you for watching.